Okay, so this is a chapter on inorganic chemistry and the metal complexes. And the first one is essentially how to name the metal complexes, what we call the nomenclature. So the first set is to give you the actual chemical structures, just like this too. And then you have to name those. Or the other example is they give you the name and then want you to write down the chemical structure as shown above. Okay, so I here give you a little kind of the quick overview on how people are using this, and particularly you start to notice this notation that is a little uncommon for general chemistry, but this is very common for what is called the complex chemistry. En is shown up here. This is from the class slide. En means the ethylene diamine. So this diamine has this amine group, has a lone pairs. The other one shown as the ligand, actually they can coordinate twice. So they are pretty effective and they're pretty strong. And also this C2O4 is also known as oxalate ion, and then it also shown as an OX, and it is a C2O4, as you can see here. So those are the oxalate ion that you can see. And something that also EDTA is very, very common, and it is so common that people just use EDTA without knowing the actual name, is a pretty long name, ethylene diamine tetraacetate. So it's more like there are like 4 ligand site, which is electron rich, that can kind of coordinate to the complexes. So it is a matter of this one has a 2. It's called a bidentate. And so they have a 2. This one 2. They have a 2 coordination 1. So these are the one very forming the sort of the more than one coordination toward the central atom, central metal complex, and that's something that you can envision here. And for example, here, the first one, you are seeing this the 2 to the ethylene diamine there. And also for the naming it, you start to see different compounds, and I would like to highlight something that is negatively charged, which is this one, cyanide ion, and thiocyanide ion is negatively charged, and even oxalate ion is a negatively charged. And this one is actually ended up with cyano, thiocyanato, and an oxalato. So those are some consistency that when you have a negative compound, then they have this name there. And also you can see that this the negative compound. You can see this all the negative compound is always hydroxyl, cyano, nitro, oxalato, right? Even the bromo, chromo. So is anything that is a negative charge has this tendency with something with a O at the end, and that's something one of the tendency that you should remind yourself. And also this is more like a neutral, right? So this is an anion versus this is a neutral. Neutral is a water is an aqua. Ammonia has a lone pairs electrons, right? And this one is amine. And then carbon monoxide has a carbonyl. And then this is ethylene diamine. And then EDTA, ethylene diamine tetraacetato. Because if you look at that, this one is also, I don't know why do they put it a neutral, but this is a negative one, so this one should have the O at the end, and because of the negative charges that the EDTA has. So EDTA is a really well-known, very strongly binding molecule there. Okay, so coming back to this example, these are the 2 examples I just selected. 3 example carbonyl. Those are the 3 ones that to show up here. So now you start to have a look at it, what is shown up there in terms of nomenclature. So this is there are two things that you need to do is identify what are the ligands. So you see the ethylene diamine, you see this aqua, water, and also the important one is what is the charge of these central atoms here, and that's something that you need to figure that one out. And then what you need is you need to look for the nature of this the charges, right? SO4 is actually 2 minus. Okay, so this is a sulfate, and yet the 2 minus charges, there are 3 of them, so this will give you -6 charges. And if you look at the cobalt, there is a 2 cobalt here, so therefore your cobalt should be 3 plus because there are 2 of them to make it neutral, right? So therefore, what you find out from the charge balances here, important one is your cobalt, this is a CO, is a +3 charges. Okay, so that's one piece of information that you know. And the second piece of information is now you have to put in the ligand in place. So diamine, ethylene diamine, right? Ethylene diamine. That's what this EN is about. And then you have 2 of them, so you're going to say bis. That means bis. And then also, what else? Water. Water is AQUA, aqua. And then how many do you have? You have a tetra. Okay, tetra aqua plus bis ethylene diamine plus tetra aqua. Okay, those are the 2. And then what you're looking for is, I want to look at in something in an alphabetical order. So this tetra and bis doesn't count in the alphabetical priority. So aqua comes first, and then the ethylene diamine comes next. And then you're going to put a cobalt. So therefore, the nomenclature for this one, the A, I think because of the spaces, I'm going to move this one up to here. Okay, and then by combining these 2 together, you are going to say, okay, so the answer is. It's probably pretty long, so I'm going to start from here. Tetra aqua bis ethylene. Okay. Ethylene diamine, and then cobalt 3, this is 3 plus, and then you can put this one is a sulfate. Okay, cobalt sulfate. So that's your answer for this coming from this block. And let's go to the second one, which is this one, this second example. So this is a potassium. So that from here you know that this is a 3 plus because their potassium is +1. There are 3 of them. So this complex, oxalato complex, it should be -3, right? And as you know, the total charge is -3, but C2O4 itself is -2 oxalato. Right? So this is a -2 is shown up here. So there are 3 of them. So it is a -6. So therefore, you naturally say, okay, cobalt, there is only 1 cobalt. To compensate them, there must be 3 plus. And so you're going to have cobalt, right? And that's a 3 plus. Okay, cobalt 3 plus. but the fate of this, the cobalt, is a little bit different because you are using the place for the anion here, right? So this one becomes actually what is called a cobaltate. Just like a sulfate, when you put this complex at the end, you will have this name cobaltate. That will be your kind of the metal complex anion, and that's how it's being shown. Whereas this one is just a cobalt itself, because they are in the cation part on this. And so therefore, let's try to finish this one up. The number B is we're going to say potassium, and then what do you say? What do you have? Do you have a trioxal? So trioxalato cobaltate. And you want to make sure that you understand show them you understand the charges, which is 3. So you can actually write tri, or the other option is you can write it as potassium TRIS. When your ligand is big, you instead of writing tri, you can say tris, and the rest is the same. Oxalato cobaltate, and plus charge 3. Okay, so those are the answer for the, I guess, changing the chemical structure into the name. And the other way around is actually it's much easier. You can imagine. So this one is okay, tetra aqua. Right. So okay. So I can write it H2O4, and then dicyano. Cyano means CN2. Okay. And then, as you know, this will give a rise to -2 charges. -2 charges, because the cyano is a negative bond. There are 2 of them, so -2 charges. And then they say iron is +3. So this is a Fe 3+. So then means 2 minus 2 plus 1. So you will have overall charges, something that you begin with. Let me change the color. Okay. So this one, you're going to write it as bracket with a plus charges. Okay, because from this you know it. And then now you say Fe, and then CN2H2O4. So that's how you're writing it. Because I think this is also, whenever there's an opportunity, this is an alphabetical order. C goes first, and then H goes later. So that's how you write choose a sequence, which one comes first. Okay, so the potassium manganate. So this means, okay, manganate is Mg3+. So that's the one, and there goes the at the end, endo. Okay, so this one is a part of the complexes. That should be somehow the negative charge. Okay, so that's why it's a manganate. And the potassium means potassium, right? But we don't know how many are there, just like we learned from the previous example, and we just have to figure that out. Okay. Okay, how do we figure it out? Hexa thiocyanato. So thiocyanato means SCN minus, and there are 6 of them, right? So if you have 6 of them, and then this is Mg2+, what you should have is, so this is how your logics should think about. Okay, so then I think that I should logically extend that. This means this is a magnesium. Sorry about that. It's a manganese Mn, right? Mn3 plus. So Mn SCN6. Right? And then this one is should be minus 3. As you see. So therefore, finally, your answer D should be, because the K is a plus 1 for each one of them, so therefore K3. And then Mn SCN6. And so that should be a potassium manganate 3, right? With a 6 thiocyanato anions coordinated. Okay, so this is the previous one is an answer for C. So those are the answers. Okay, so those are the answers, and that's the answer. And if you go down, then you can check the cleaner answer for yourself and how this is provided from the generic answer system.